Lesson 6-5, Use Proportionality Theorems. By the end of today's lesson, we will be able to successfully use proportions with a triangle or parallel lines. The triangle proportionality theorem, or it has another name called the side splitter theorem, states that if a line parallel to one side of a triangle intersects the other two sides, then it divides the sides proportionally. So what this means is if TU is parallel to QS, so if a line is parallel to one side of a triangle, intersects the other two sides, so T and U are the intersections of the other two sides, QR and SR, then it divides the sides proportionally where RT to TQ, the ratio of RT to TQ is equal to the ratio of RU to US. A detailed proof of this theorem is illustrated on my website. Please visit my website to see how it's being proved. And the converse of the triangle proportionality theorem states that if a line divides two sides of a triangle proportionally, so this is just the opposite, so the TU will be the line, and then divides the two sides proportionally where RT to TQ is equal to RU to US, then we can say that this line is parallel, TU is parallel to the third side, QS. So again, TU is parallel to QS. Example 1, Part A. Find the length of QU. So again, we can use the triangle proportionality theorem or the side splitter theorem. Okay, then I am going to let QU be X, and I can go ahead and set up my proportion. 10 to X equals 12 to 6, and I can simplify. So X equals to 5. And then the next one, Part B, find the length of KL. Again, I could do set X for KL, and I can do X to 18, 44 to 24. And then I can simplify. 18 divided by 6 is 3, 4, 11. So cross multiply, X equals 33. Example 2. Determine whether segment QT is parallel to segment RS. Well, we need to check if the sides are proportional. So 18 to 38 simplifies to 9 to 19, and then 36 to 80 simplifies to 9 to 20, but these two are not equal to each other, so we can write no. The proportions are not equal. Part B, given the information, determine whether BD is parallel to AE. So I can do 27 to 23, and 27 to 23 is not equal to 19 to 31. So again, no. The proportions are not equal. Theorem 6.6 states that if three parallel lines intersect two transversals, so the three parallel lines here are R, S, T, and the two transversals are L and M, then they divide the transversals proportionally. So we can say UW to WY is equal to VX to XZ. So this is just another formula that you need to know, given this case. And another theorem, 6.7, if a ray bisects an angle of a triangle, so this would be the ray, then it divides the opposite side, so the opposite side would be AB, into segments whose lengths are proportional, so AD to BD, as illustrated here, are proportional to the lengths of the other two sides. So that would be CA to CB. There's also a proof to this theorem on my website. It is highly recommended that you go to the website to read the proof. Okay, now let's apply these two theorems. A farmer's land is divided by a newly constructed interstate. The distances shown are in meters. Find this distance CA. So CA between the north border and the south border of the farmer's land. So first of all, I need to find the length of BC. So by theorem 6.6, I can set up a proportion, 2000 over x equals 2500 over 3000. And I can simplify. Let's cancel out two sets of zeros. And then simplify the right-hand side. And then simplify. So x equals 2400. And I need to take 2400 because I need to find the length of CA and add it to 2000, which makes 4,400 meters. Example 4. In the diagram, angle DEG is congruent to angle GEF. So we can conclude that EG is the angle bisector of this angle DEF. So use the given side lengths to find the length of DG. And we want to find X. And because EG is the angle bisector, we can use theorem 6.7 and set up a proportion. Okay, so since the total length of DF is 14, I can say GF is 14 minus X. So my proportion would be X to 14 minus X and then 8 to 12. So DG to GF equals to DE to FE. Let's simplify. 8 divided by 4 is 2 and 3. So 2 times 14 minus X. Cross multiply. 28 minus 2X. And then this would be 5X equal to 28. And X would equal to 5.6. Okay, now let's do 2 more practice problems. Find the length of AB. Let this be x, and by theorem 6.6, I could set up a proportion. X to 27 equals to 32 to 24, and we can go ahead and simplify before we cross multiply. Use 8. So x equals to 36. And for this one, again, we can use theorem 6.7, and I could do 1 to 1, square root of 2 to AB, and let that be x. So x is just square root of 2.